Hello everyone. Today we are going to see an interesting topic, that is your electricity. So far we saw light chapter, and next we are moving into the next chapter, that is your electricity. So when you hear the term electricity, there will be a lot of things coming in your mind. But I just want uh, you to ask one question. It's a simple thing, don't get afraid. Do you rely on electricity like you do food and water? What would life be like without electricity? To power your favorite video games, television shows, telephones, and even the lights you read by at night. Just think, without electricity, you wouldn't be able to enjoy your daily wonder of the day. What a horrible thought. But don't worry, electricity does exist and it allows us to enjoy life in so many ways. So, Sir Benjamin Franklin, he was the one who coined the term electricity using a simple kite experiment. Actually, the electricity is a natural thing. Like it need not be invented by someone, it has to be discovered. And that thing was used properly by Sir Benjamin Franklin. He was trying to explain that electricity is available in nature. So, using his kite experiment, he proved electricity exists naturally. So, what was the kite experiment is? He wanted to show that lightning was also an electricity. So he flew a kite during a thunderstorm. But to his kite, he tied a metal key to the kite string to conduct electricity. Just as he thought, electricity from the storm clouds transferred to the kite, and electricity flowed down the string and gave him a shock. But luckily, he didn't get hurt. But he didn't mind the shock since it proved his idea. So, building upon Franklin's work, many other scientists studied electricity and began to understand more about how it works. And in 1879, Thomas Alva Edison patented the electric light bulb, and our world has been brighter ever since. But before Thomas Alva Edison, the man behind that term electricity was Sir Benjamin Franklin. And he discovered it maybe in 17th century or the end of 16th century. So, coming to the point, electricity has an important place in modern society. It is a controllable and convenient form of energy for a variety of uses in homes, schools, hospitals, industries, and so on. But how do this electricity flow? When you switch on, your light is on. When you switch on, your fan is on. And you want to charge up your phone, the after 1.5 hours, your phone is fully charged. And when you go to the kitchen, your mixie is running, so you can grind everything. And you can do the washing machine, and when you put when you switch on, the machine just wash your clothes. So everything is done using your electricity only. So you may wonder, what is this electricity and what makes it So it is simple. Electricity is a flow of electrons. A flow of electric charge is known as an electric current. In electric circuits, this charge is often carried by moving electrons in a wire. But what does an electric circuit mean? What does it mean actually? And what is the unit of current? And how do we calculate the number of electron passing? And it constitutes just 1 coulomb of charge. So we have a lot of questions. How do they? What are they? And inside the circuit, how will be? And how it is functioning? So let's give an answer for these questions. Electric current and circuit. So a basic a thing in everyone home, it's a torch. And you'll visualize the battery inside the torch, and everyone each and everyone will get they'll have a chance to change the battery, right, when the battery dies. So you'll see the positive and negative terminal of the battery, so it has to be fitted properly. And we can also call that one as a cell. We can call that one as a cell too. So when placed in proper order, provide the flow of charges or an electric current through the torch bulb to glow. So, but it doesn't glow all the time. There is a switch in the torch, right? So when you are switching on, you'll get a flash of light, and when you switch off, your flash of light dies. So we have also seen that torch gives light only when it switches on. What does that switch do actually? What does the switch do? Fitting the battery doesn't mean that your torch will glow always, right? Okay, there should be some operating agent. So a switch makes a conducting link between the cell and the bulb. Got it? A switch makes a bridge, I can tell, between operating between your bulb and the cell. So what is an electric circuit? So far we saw what is your electric current. So electric current is nothing but flow of electrons. And we have to put that in a proper circuit. Then only we can use it, right? So an electric circuit is a continuous and a closed path of an electric current is called an electric circuit. Now, if the circuit is broken anywhere, or the switch of the torch is turned off, the current stops flowing and the bulb does not glow. So when there is something in the circuit, it's not switching on, your wiring would have been damaged somewhere else, or the switch is a problem. So these are the things when the current stops flowing and the bulb does not glow. But electric current has to be expressed. So everything we cannot tell orally. Okay, so far what we saw, a current is nothing but a flow of electrons. But we have to call it like not every time a current, electric current. So when I need to operate electric current, so there are so many uses we saw, like in industries, in hospitals, and in home. And the power required in industry and hospitals are more than the home. So there should be some operating numerical value for that. So actually, physics is more related to mathematics. So we need to give a formula for that, and it should have a unit. The amount of charge flowing through a particular area in a unit time That is your electric current. So the charge flowing in a unit time, like in per time. So if a net charge, there is a charge Q flows across any cross section. Cross section of a conductor is nothing but the shape of the conductor, the length and breadth and height. In a time t, so how long it is taking? Then the current I through the cross section. So all the three things are connected. That is, your I is equal to Q by T. So what is your current? The charges flows in a time. So what will be the unit of this is the SI unit of electric charge. This is your system of unit of electric charge. You can call that as a coulomb. And it is denoted by C. Coulomb, and it is denoted by C. So, in a circuit, so far I talked about the battery, and in Benjamin Franklin experiment also, what Benjamin Franklin was doing, he just tied the metal strip at the end of the kite, right? So if a current, like the electrons need to flow, there should be a proper conductor, that is a wiring. So using a metallic wire, electron constitute the flow of charges. So, but the thing, electrons were not known at the time of the discovery of electricity, because it was mid 16th and the starting of 17th century when the phenomena of electricity was first observed. So, electric current was considered to be the flow of positive charge, and the direction of the flow of positive charge was taken to be the direction of the electric current. So it was just concluded that electric current was just the flow of positive charge considered. It was just considered. And the direction of the flow of positive charge was taken to be the direction of electric current. Conventionally, in an electric circuit, we are talking about the electric current. But in an electric circuit, it is taken as in the opposite manner. That is, the direction of electric current is taken as an opposite to the direction of the flow of electrons, which are negative charge. So, the electric current is opposite to that of the electric circuit. So what is the unit of electric current? So far we saw the unit of charge, that is the electrons. So what will be the unit of electric current? So the electric current is expressed by a unit called ampere, which is denoted by A, named after the French scientist like Henri-Marie Ampere during the year 1775 to 1836. So if one term is being introduced by one scientist, the upcoming people will not neglect the discovery of one scientist unless the discovery tells something that is not matching their assumption. But the people or the people who are following the theories, the discoveries of the past scientists will just give all the things related to him, so they'll not miss it. So it was just introduced by, the idea was given by Benjamin Franklin, then Thomas Alva Edison, then Ampere, then so many people just came and gave the complete body of electric current. So what will be your 1 ampere is actually, 1 ampere is what? So 1 ampere is constituted by the flow of 1 coulomb of charge. So 1 coulomb of charge per second. 1 coulomb of charge per second, that is 1 ampere is nothing but 1 coulomb per 1 second. Like small quantities of currents are expressed in milliampere. that is expressed by this. Milliampere is nothing but 10 power minus 3 ampere, small quantities. These are the things we use in the laboratory, in physics laboratory for the experiments, and or in the microampere. So these are the symbol of micro, that is 10 power minus 6 ampere. So this is a simple problem related to the formula, what we saw before. There is the electric charge and the electric current. What this problem say is nothing but a current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit. So in the above thing, they have given current, that is your I. They have given your time, that is your 10 minutes. So minutes, I'm just converting into your seconds because I have to stick to my units. So what will be your formula actually? They are asking your electric charge, that is nothing but your Q. So Q is equal to IT. So what is your I? 0.5 amps into 600 seconds. So when you multiply this, you'll get 300 coulomb. The electric charge will be 300 coulomb. And if they ask something different here, so they are asking Q, so Q is equal to IT. If they're asking you I, you can rearrange, or if they're asking you T, you can rearrange, right? Next, we are moving into your electric potential and potential difference. So after your electric current, after your electric circuit, we are moving into your electric potential and potential difference. Like how the charges are moving. When you connect to positive and negative terminal of the battery or a metal strips, how do they move actually? There is some a magical force which pushes them to go? No, it's absolutely wrong. So it is nothing but your electric potential and potential difference. These two people do it. Electric potential and potential difference. These two people do that work. Let's see, what are they? Electric potential. So, what is electric potential? Electric potential is defined as the capability of a charged body to do work. So it is the inbuilt ability of a charged body to do work. That is your electric potential. If some body is charged, it has to do some work. So that is called as your electric potential. So when the body is charged, either electric electrons are supplied to it. So how the body is charged? If I give some charges to it, that is the electron to it, or they are removed from it, either I give them or supply them, or either I remove the charges from them. In both of the things, there is some work done in it. So in both the cases, the work is done. This work is stored in the body in the form of an electric potential. So whatever the work I'm doing, either I'm just giving the charges to that particular body, or either I'm removing the charges from the particular body, a certain work is done to it. And that work is stored in the body in the form of electric potential. Thus, the body can do the work by exerting a force of attraction or repulsion on the other charged particles. That only the charged bodies do. So this is nothing but your electric potential. How the electron moves inside a circuit. So far we saw the electric charge, the electric current, the electric circuit, electric potentials, and how literally the electrons move actually. There should be some force, right? There should be some force to just push your electrons to just move inside the circuit, but not exactly, it's not a force. There should be some electric pressure. Then only the electron will move, right? So the electrons move only if there is the difference of electric pressure called the potential difference along the conductor. This difference of potential may be produced by a battery. When I attach a battery, that is a positive and negative terminal of the battery which is connected to the circuit, I am just giving an external supply to them, to the circuit, so that it will create an electric pressure so the electrons are moving inside the circuit. Or I may also connect one or more electric cells to it. But normally, like in your torch and all, the battery will be stored inside, right? So you'll not remove it. But the chemical actions will be taking place. But the torch will not glow unless the switch is on, right? So the same thing here, the chemical action within a cell generates the potential difference across the terminals of the cell even when no current is drawn from it. So a perfect electric pressure is maintained even when the current, I'm not drawing any current from it. Even when I'm not drawing a current from it, your chemical actions will generate your potential difference. So now when the battery is connected to a conducting circuit element, the potential difference sets the charge in motion in the conductor and produce the electric current. Got it? So this is the difference between your electric potential, okay, electric potential, and this is your difference of pressure. That is your potential difference. In order to maintain the current in a given electric circuit, the cell has to expend its chemical energy stored in it, right? So if you're we will not change the battery when the torch is not working. We'll just take the positive negative, we'll just rub them and we'll just put it back. But even then, if you put it back, the torch will not work. What is the meaning for that is that your chemical energy stored inside the battery, the time has been over, right? So it will repeatedly use your energy whenever you're switching it on. So there is no other way. You have to use the other battery setup. So this is how your electron moves. And this is the force, that is the potential difference, is the force behind them. And I told you, if there is a theory, there should be a mathematical script for that. So what will be the unit of potential difference? What will be the unit of potential difference? So what did I tell you? A potential difference is nothing but the electric pressure between the 2 points, right? So the electric potential difference between 2 points is an electric circuit carrying some current. As some current means there is some work is done, right? So it is nothing but the work done to move a unit charge from one point to the other. So a potential difference is I have to move the electrons from one point to the other point. So it is the work done to move a unit charge from one point to the another point. So the potential difference is denoted by the letter V between 2 points. Is nothing but the work done W divided by the charge Q. So whatever work done by the charge. So V is equal to W by Q, and this is also the important formula as your current I is equal to Q by T. And this also we can change depending upon the numerical value. If V is given, you will automatically write W by Q. And if W is if they want like W is wanted, you'll just rearrange like V into Q. So the system of unit of electric potential difference is named volt, that is V. Actually, it is named after Alessandro Volta during the year 1745 to 1827, and he's an Italian physicist. So this is the unit of potential difference. This is a unit of a potential difference. So we saw what is like 1 ampere, and the same thing. What is 1 volt? So 1 volt is the potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to other. That is, work is done in moving 1 coulomb of charge one point to the other point. That will be calculated as a work done. So for work it is joule, right? So therefore 1 volt is nothing but 1 joule per 1 coulomb. Okay, so when I take the numerator, I'll get per. So the potential difference is measured. This potential difference is measured by means of an instrument called the voltmeter. So how will we measure the potential difference? The potential difference will be measured by voltmeter. The voltmeter is always connected in parallel across the points between which the potential difference is to be measured. So where you want, like exactly where you want to measure the potential difference, your voltmeter is connected parallel across the points between which the potential difference is to be measured. And the corresponding problem, that is, how much work is done in moving a charge of 2 coulomb across 2 points having a potential difference of 12 volt. So what are given in the question? Work done is like, I need to find the work done in moving a charge of 2 coulomb between 2 points, and the potential difference is 12 volt. So the amount of charge Q that flows between 2 points, the potential difference of V 12 volt is 2 coulomb. So the amount of work done. So I'll just like when I rearrange the formula, I'll get W is equal to VQ. So what is your V? 12 volt. What is your Q? 2 coulomb. So when I multiply it, I'll get 24. Like V into coulomb, it's nothing but your joule, right? Work done. So 24 joule. It's a simple problem. And you can just rearrange this if you want the data, whatever data you need. So this is some component used in electric circuit. That is the symbol, like an electric cell. Can you see this electric cell? An electric cell will be denoted like this. The positive will be bigger than the negative. A battery. So when I want to attach a battery, like a repeated connection of a battery or a combination of a cells, you will have like this. So you'll just connect again the positive negative, again the positive negative. So this is a plug key or switch is open. So when I want the circuit to be open, I'll just there will be a plug key in the circuit. I'll just open it, so the switch is open. So when the plug key or a switch is closed, the symbol will be like this. So a wire joint. So if I'm having a a wire. So when the wire is joined, we'll denote it by the symbol like this. Wire crossing without joining will be given by this symbol. Electric bulb will be given by both of the thing. Resistor of a resistance will be given by like this, like a resistor, the 10 ohms, 20 ohms, like that. But variable resistance, or also called rheostat, you will have an arrow mark like this. That is, we can change it, we can vary it. That is the name of variable resistance. Then is your ammeter and voltmeter. Ammeter is denoted by A, voltmeter is denoted by B. Current can be measured by ammeter and the voltage can be measured by a voltmeter. Using all these people, we are moving into the important law, that is your Ohm's law. So what is your Ohm's laws? The Ohm's law is based on a relationship between voltage, current, and resistance. So all the three peoples are linked in the same law, that is your Ohm's law, or the link between electric current and potential difference is described by Ohm's law. I can also put it in like that. So who discovered this famous Ohm's law? George Simon Ohm, a German scientist, was the first to verify this Ohm's law by experiment. So he was the one who connected all these three datas into one formula. Can you see these three peoples? The three peoples are just pushing your current, and the home also is doing that. The volt is also doing that. The Ohm, volt, amp. So this is your famous Ohm's law. V is equal to IR. This shows voltage is directly proportional to current. So the voltage. So when the voltage is increased, your current is also increased. So this shows voltage is directly proportional to current. So now what is your V? V is the voltage or potential difference of a conductor. I is the current flowing through the conductor. R is the resistance. So yeah. So if when I rearrange it, I'll have, so from here, when I rearrange it, I'll have I is equal to V by R. So we can find current by the above formula if voltage and resistance are given. That is R is equal to V by I. So we can find the resistance using the above formula, that is R is equal to V by I. And we can find the current using the above formula, I is equal to VR. And this is the representation of Ohm's law. And this is nothing but your Ohm's law circuit. See, all those things are connected using this wire. It's just the picture of it. So if I want to perform the Ohm's law, what are all the materials required for that? You will construct a simple circuit using a single known resistance R. So I'm going to construct it, and along with me, you're going to construct it. So then you will use an ammeter to measure a current. We saw it before. That is current, and through the resistance, and voltmeter to measure the potential difference V across the resistance. So with this data, you can check the validity of the Ohm's law, whether V is equal to I. So just going to check whether V is equal to I. So can you see the setup now? So there is an ammeter over here, and there will be a voltmeter which will be connected parallelly to the 2 points, and there will be a battery, and there will be a plug key, and there will be a resistance. So a fixed resistance, I'm going to fix it. So whether I'll be having a perfect numerical value for that, exact numerical value for that, that is fixed. So your resistance R will be fixed. So I'm not going to change it. So it is fixed. Set the value of the electromotive force into a certain voltage. An electromotive force, that is your the electromotive force. I'm just fixing that value for that. You can get different reading of current I and voltage V by varying the battery source. So I'm just going to vary my battery source, so that when I vary my battery, I'll get a different value for each and every time for my ammeter and my voltage value, that is my current and volt. Record the value of current to the resistance and voltage across it. So I'm going to record the value of current through the resistance. So fixing the resistance and the voltage across it. So repeat the step 3. Which step? This step. So by varying the battery for each and every value, I'll get an ammeter and voltmeter value. So to get at least 6 different readings. So you record this table, record the data in the table that I'll be showing in the next slide. Repeat the previous step for another value of resistance. So I'm just fixing this, how can I tell, like 10, and it is denoted by ohms, your resistance. And again, I'm changing my resistance value so that I can check whether my current and old values are changing or varying. So this is a table. See, I have kept R as 1. This is ohms. This will be called kilo ohms. So R is equal to kilo ohms. I'm fixing the resistance. So when I'm fixing the resistance and changing the value of the battery, I'll get the current and the voltage value. The resistance will be the same. So average resistance, that is R average, that is your the resistance value will be the same, right? So resistance from the slope. So when I plot this current and voltage in a graph, let's see, you'll get like this. See, this will be your x-axis potential difference, y-axis will be your current, IV graph for the fixed resistance. So what do you see actually? There is a straight line. So the component which shows a straight line, IV graph, or linear circuit element, that is, they are also sometimes called ohmic circuit, I can tell. This means that current is directly proportional to the potential difference. So if I get a straight line, so whatever value of current, I'll get the particular value of volt. So this is called Ohm's law, and it's true for the fixed resistor or the resistor wire at constant temperature. Whether I can use a fixed resistor or resistor wire which is operating at a constant temperature. So but this is the easiest and simplest method, and the circuit is also simple. So whenever you just change the battery, like when you just change the values in the battery, you'll get the current and the volt value getting changed. You just put it in a graph and just check if this I is proportional to B. So next I have to tabulate my result. So the plot a graph of voltage V and the current I with V on the vertical axis and I on the horizontal axis. I'll get a straight line, and I have to find the slope of a straight line, which is the resistance R in the case. That is anywhere else, if I find a slope value, that is a slope value, that will be equal to my R2, R, which is the resistance R in this case. So that's it about your Ohm's law. And this is one of the problem related to your potential difference and all your work done, everything. Let's see. The potential difference between the terminals of an electric heater, the terminals, so is 60 volt. When it draws a current of 4 amp from a source, what current will the heater draw if the potential difference is increased, if I'm increasing it to 120? Hope the question is clear for you. So initially, between the terminal of the electric heater is 60 volt. It draws from 4 ampere current. So when I increase my potential difference to 120, my current will be the same or it will be a difference. So what will be my current? Let's check with the help of this formula. So we are given a potential difference V is equal to 60 volt and current I is equal to 4 amp. So according to Ohm's law, V is equal to IR. So now what I'm doing is my work is I need to find the resistance for that particular electric heater 60 volt draws 4A current from the source. So R is equal to V by I. So when I do it, 60 volt by 4 ampere is nothing but 15 ohms. So using this 15 ohms now, so when the potential difference, if I'm increasing to 120 volt, so unless and until if I don't know my resistance, how do I find my current? So I is equal to V by R. For the next thing, increased voltage, it is my 120. So 120 volt by 15 ohms, I'll get my current 8 amp. So whenever the current, whenever the potential difference is increased to 120 volt, the current to the heater becomes 8 ampere. So if they're asking in the either way, so you can just rearrange it. You can just rearrange it. If I and R is given, you can calculate your V. So you can use the formula once when you are into it. So when the question is given, you can use the formula with the given numerical value, and you can exactly find the what parameter you need to find. So next is your factors on which the resistance of the conductor depends. So a resistance plays an important role in your Ohm's law. So what are the factors on which the resistance of a conductor depends on? So resistance is nothing but the opposition, right? A resistance. You don't have a resistance to oppose something. So what factor is depending upon the resistance? So we'll see the factors depending upon the resistance and so on, the formula regarding to the resistance in your next session. Thank you.